Good morning and welcome to Mrs. Merkel's Trig class. We're going to start with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu in mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri et Filii, Spiritus Sancti. Amen. Okay, let's get started. This is take 2, so I have a couple things on the sheet already. We get to skip a couple chapters and start chapter 12. So chapter 12 is angles and degree measure. So a degree is equal to 1/360th of a complete rotation. So if we start here, this would be our initial side. And we draw our angle over here, and that's our terminal side. So you start at your initial side, and you go around to the terminal side. So here we have about a 225-degree angle. That's positive, and as far as angles goes, counterclockwise is positive. So let's say that I had my initial side here, and I wanted to go counterclockwise. This would be a negative 60-degree angle. Standard position is when the initial side is on the positive x-axis. And there's another term we need to know. It's called a quadrantal angle. And that is where the terminal side is on an axis. So an example of a quadrantal angle would be a 90-degree angle, 180, 270, 360, and so forth. Okay, let's go over the quadrants in case we've forgotten our quadrants. This is quadrant 1. In quadrant 1, both the x and the y are positive. And we go counterclockwise. This is quadrant 2. In quadrant 2, we have a negative x value and a positive y value. Go down here to quadrant 3, where we have a negative x and a negative y value. And over here to quadrant 4, where we have a positive x and a negative y value. Okay, so that gets us started. A lot of this is a little bit of review, which is good. We could use that. Okay. If two angles, this is the definition of coterminal. Okay. So two angles in standard position are coterminal if their terminal sides coincide. Okay, so let's take a look at an example of coterminal. So let's say I've got an angle, which is here. Okay. So let's just make this a 30-degree angle, okay? If I want to make a coterminal angle, I've got to make it end right here. So if I start here and go around, my coterminal angle is 360 degrees plus 30 degrees, which would be equal to 390 degrees. So the angle 30 degrees and 390 degrees are coterminal. And we can write a coterminal angles. So the measure of all coterminal angles, so if theta is our angle, okay, theta plus 360 times n will give us a coterminal angle as long as n is an integer. Okay, so for our example, we went around, our n was equal to 1. So we could go around 2 times plus the initial 30-degree angle, and that would give us another coterminal angle. All right, next what we're going to do is we're going to talk about degrees, minutes, and seconds. So we already know what a degree is. If I say I have a 1-degree angle, it's 1/360th of a complete rotation. Okay. 1 minute is written like this, 1 minute. And that is 1/60th of a degree, which is 1/21,600 of a complete rotation. I just multiplied the 60 times the 360 and got the 21,600 of a complete rotation. The next one is a second, and it's written with 2 little lines. And that is 1/60th of a degree. 1/60th of a minute. Okay, so you can say that it is 1/3600 of a degree, or you could also say it is 1/, of a complete rotation. Okay, and that's basically, it's smaller. It's just breaking it down into smaller units. So we know we're used to working with degrees, which is 1/360 of a complete rotation. 1 minute is just 1/60th of a degree, and 1 second is 1/60th of a minute. And we'll go over an example so that you can see how that works. So if we have an angle which is 14 degrees, 36 minutes, and 54 seconds, we are going from degree, minutes, seconds to decimal form. So we start with your 14 degrees because that's already where it needs to be. So we have 14 degrees plus, all right, so remember, 36, we'll have to have 36 over 60, okay, plus 54 over 3,600, and, 3,600. So that is equal to 14 degrees plus, if you put into your calculator, 36 divided by 60, you'll get 0.6, plus 54 divided by 3,600 is 0.0158. So our angle taking it from, now we have to add up the 14 degrees plus the 0.6 plus the 0.0158. So our angle is actually, in decimal form, is 14.615 degrees. All right. So for if you're converting degrees, you divide by 60. If you're converting minutes, you divide by 3,600. So let's say they give us something in decimal form. So let's say I have 72.568. 72.568. That's in decimal form. And I want to change that to degree, minute, seconds form. All right, so what we do is we start out with the 72. That stays the same. All right. Then what we do is we take what's left. We take the 0.568 and we multiply that by 60. See, before we divided by 60, now we're multiplying by 60. So what that gives us is 72 degrees. And when you multiply 0.568 times 60, you're going to get 34, okay? That's the 34 minutes. But you're going to have a little bit left. You're going to have 0.08. So then we're going to take that 0.08 and multiply that by 60. So you have 72 degrees, 34 minutes, and 4.8 seconds. So that takes us from a decimal to the degree, minutes, seconds form. Okay, let's take a look at some examples so that you can do your homework. Okay, so I'm going to start doing the even ones so that you'll have the examples to the evens, and then you can check your work in the back of the book and you can see whether or not you got them right. All right, so I am on page 552. Let's take a look at number 2A. Okay, so number 2A, we have, let me take a look at that. All right, it says sketch each angle in standard position, indicate the rotation by a curved arrow, and classify each angle by its quadrant. If the angle is a quadrantal angle, say so. So if you look at 2A, they're telling us to sketch a 40-degree angle. So remember, this is just a sketch. You don't have to get your graph paper out, okay? So let's draw our axes here. Okay, halfway is 45 degrees. So to draw a 40-degree angle, we're going to go slightly less than halfway. Okay, and then we have to draw our angle here, the arrow. Okay, so that's our 40-degree angle, and we are in quadrant 1. All right, so let's take a look at 2B. Now 2B says we need to sketch a negative 40-degree angle. So we'll put our axes on here like this. Okay, negative just means that we go clockwise, so slightly less than halfway, and that gives us a negative 40-degree angle. Okay, all right, let's try another example. Let's take a look at number 4A. Okay, 4A wants us to sketch a 270-degree angle. So we'll put our axes here like this. Okay, so now think about this here. So if we have a 270-degree angle, we know that if we get to 180 here, I misspoke. I'm sorry. It was a 240-degree angle. Because if we go from here to here, it's 180. And from here all the way to here, it's 270. Okay? And the book is looking for a 240-degree angle. Okay? So if we take a look at the 270 minus the 240, you're going to be all the way around, and you're going to have 30 degrees left to go here. So we'll put our angle here like this. Okay, so this would give us our 240-degree angle. Okay, and that 240-degree angle is in the third quadrant. Okay, So now, but let's take a look. So 4B says we want a negative 240 degree angle. So now let's think about this. We've got to go clockwise now. So we're starting here. This is our initial side, okay? If we were to go 3 quadrants, that would be 270, okay? But we only want 240, so we're going to put our angle there. And this is negative 240 degrees, okay? So we just have to get ourselves familiar with the 90, the 180, and the 270, and the 360, and then we can draw our sketches from there. All right, let's take a look at number 6. Number 6A has us doing a 300 and, let's see here. I want to take a look at that because in the last one, 315 degree angle. Okay, so think about this here. If we go all the way around, it's 360. So what if I take 360 minus the 315? We need to have 45 degrees left. So this angle is actually going to be right here, okay? And so then we want a 315 degree angle. So this is our initial side, and we go all the way around to there. And that is doesn't matter where you put you just have to label it. So we'll put it up here, 315 degree angle. Starts here, goes all the way around to here. This is actually a 45 degree angle here, okay? And so that gives us, oh, we forgot to label the quadrant on this one, our negative 240. Our negative 240 was in quadrant 2, okay? The 315 is in quadrant 4. All right, good. All right, let's take a look at 6B. 6B tells us that there is no 6B. Fantastic. All right, now let's take a look at number 8. Number 8 says that we need a negative 90 degree angle. Okay, so if this is our initial side, we need to go negative, so that means we're going to go clockwise, and this is a negative 90 degree angle. And it said specifically if it was a quadrantal angle, we would label it. So that is, we'll just label that quad there. Okay. All right, let's take a look at the next one, number 10. Now, number 10 is interesting. All right, number 10, they want us to go 1,080 degrees. Okay. All right, so we've got to figure out where 1,080 degrees is. It's pretty big. So let's take a look here. Let's say I've got 1,080 degrees. And can you see my calculator here? If I go 360 degrees around, all right, then I have to go 720 degree angle. So I subtract another 360, and that's a 360 degrees. And then, so it looks like it's going to be a quadrantal angle, but let's take a look at where the 1080 is, okay? So what happened was, as I started with the 1080, okay, and I went around 360 degrees, okay? So we start here, and these are kind of fun because you get to make a spiral, okay? So here's our initial side, and we go over to here, that's 360 degrees. Okay, so we're going to go another 360 degrees. So that brings us around again like that. Okay, and we still have one more 360 left to go. So if we go around one last time, that is our angle of 1080 degrees. All right, that was number 10. All right, so let's take a look. Now this was also a quadrantal angle, so we have to label that. All right, let's take a look. Now with you guys can make it smaller, but obviously with the permanent marker made it a little bit bigger. Okay, so let's take a look at another one. Let's take a look at number 12. Number 12 wants us to draw a 750 degree angle. Oops, 750 degree angle. All right, let's take a look. Let's see where their 750 degree angle is going to take us. Okay, so got our calculator here. Let's take a look. So if we take our 750 degree angle and we go around one full rotation, that's going to be we still have 390 left to go. So we'll start at our initial side and we'll go around to here. That gives us 360, okay? Now think about it. We're going to go another complete rotation, and we'll still have 30 degrees left to go. So we go around another one, okay? And now we still have 30 degrees left to go. So that means that our angle is going to come out right about there. Now remember, it's a sketch, okay? So this is our 750 degree angle, because we went around 2 times, but then we had to go an extra 30 degrees, all right? I think, are we still telling quadrants? Yes, the 750 degree angle is in quadrant 1, okay? All right, that was number 12. All right, we're doing good. All right, let's take a look at number 14. Number 14 just has things worded a little bit different. Number 14 says 3/8 of a counterclockwise revolution. Okay, so we want 3/8 of a counterclockwise revolution. All right, so how do we figure out what we're going to do? Any suggestions? Oh, this is just too weird. All right, so this is one thing I can tell you, I never in a million years would have ever thought that I myself would have a YouTube channel. God surprises us sometimes, right? Okay, so a complete revolution, how many degrees is a complete revolution? It is 360 degrees, all right? So a complete revolution is 360, okay? So what we're gonna do is we're gonna multiply the 360 times 3/8, okay? So if you know how to use the fraction key on your calculator, feel free. Otherwise, you're gonna say 360 times 3, and we're going to divide by 8, and your answer is going to be 135 degrees, okay? So for number 14, we just now need to sketch our 135 degrees, which looks like, okay, now let's think about this here. If we go 90, okay, oops, got rid of that 135, okay, minus 90, we still need to go another 45 degrees. Okay, well, 45 is halfway, so we'll put it right here. Oops, the pen doesn't like to write on its side. Okay, so that gives us, start at our initial side, end at our terminal side, and that gives us our 135 degree angle, which is 3/8 of a counterclockwise revolution. Okay, that was number 14. Okay, let's take a look at 16. 16 wants us to say 1/6 of, now this is a clockwise rotation, okay? So it's 1/6 of a clockwise revolution or rotation. So what we'll do is we'll say 1/6 times 360, which is equal to, that was pretty easy, 60 degrees. Okay, but remember for this one, it is a clockwise rotation, so that means we have to go clockwise 60 degrees, and that will give us a negative 60 degree angle. All right, looking good. Let's change our paper here and go over a couple more examples. All right, so I think we got that. That's not too bad. Now let's take a look at number 20. Let's see what they want us to do on number 20. All right, number 20 says, sketch each angle in standard position when n equals 0, 1, 2, and -1, okay? So let's take a look at number 20. Number 20 says, so remember, these are going to be coterminal angles. So we have -30 degrees, okay, plus n times 360 degrees, okay? So we have n is equal to 1. Now notice I did it a little bit harder, not harder, but we have a negative sign there. Let's take a look when n is equal to 1. So we have -30 degrees plus n is 1, so 1 times 360 is going to give us 360. So when n is equal to 1, negative 30 plus 360 is going to give us a 330 degree angle. Okay, so let's sketch our 330 degree angle. Okay, think about it. If we go all the way around, that's going to be 360, but we only want 330, so we're going to be in this fourth quadrant over here, so we're going to put it over here. Let's see here, 330. I'm going to be up here like that. All right, so the first angle when n is equal to 1, we're going to start here, and we're going to go around to here. And that is going to be 330 degrees. Okay, that's when n is equal to 1. All right, let's take a look at when n is equal to 2. We have negative 30 degrees. All right, plus, now n is equal to 2, so 360 times 2 is equal to 720. 720 minus 30 is equal to 690. All right, when n is equal to, yes. Oh, I forgot n is equal to 0. That's what I was looking for. All right, we'll do n equals to 0 in a minute, but let's take a look at our 690 here. So n is equal to 2. So let's draw that here. Now remember, it's coterminal, so it's going to end up in the same spot. The question is how do we get there? Okay, so let's think about this here. This was our 330 degree angle. We've now got to get to 690. I want to show you that it actually works. Okay, so let's take a look. So if we start out with our 690 degree angle, okay, then we go around one time. That's going to get us, oops, oh, whoa, hands acting up this morning. All right, let's take a look. So we want to get to our 690 degree angle. So if we go around one time, we still have 330 degrees left to go. Looks familiar, doesn't it? Okay. So we go around once, that gives us, now we still have 330 left to go. So that means this is going to be around, well, this is going to be, so 330, we're going to go around again and to there. Okay. So that gives us our 690 degree angle. All right, let's go back to n is equal to 0 because I completely forgot to do that one. All right, when n is equal to 0, we have negative 30 degrees plus 0 times 360 will just give us 0. So when n is equal to 0, we can actually put this on our first one. Let's put it here so I don't have to sketch it again. That's our negative 30 degree angle. And remember, these examples are all coterminal. This is the formula for when something is coterminal. You take your theta plus n times 360, and n can be any integer. So we have n equals 0, 1, 2, and let's finish off this problem. Look at this. This is interesting. They want n to be equal to negative 1. Remember, I said it could be an integer, but don't abandon the process. Do exactly what it says. So when n is equal to negative 1, we have negative 30 degrees plus, okay, so we have negative 1 times 360 degrees. So that's going to be negative 30 degrees plus a negative 360 degrees. So your angle is negative, well, I don't think I need the calculator for that, 390 degrees, okay? So let's sketch it. It better come out right here, but let's take a look. Okay, so this is our initial side, and we're going around clockwise. If we go around clockwise one time, that's 360. We still have to go another 30 degrees, which will be right there, and it's in the same spot as our other coterminal angles. Okay, so that just gives you an example of working with coterminal angles. All right, we're almost done, I promise. let's take a quick look at number 24, and then I think we're done. Let's take a look. Well, let's look at 24, and then I'll see what we're going to do. Make sure I did enough examples so that you can do your homework. All right, number 24. All right, number 24 says, oh, that's right. We already did the examples for the degree and the minutes, so that'll be part of your homework too. But let's take a look at number 24. Number 24 says, use the formula to find two angles, one positive and one negative, that are coterminal with the given angle. Okay, so 24, we have a 140-degree angle. Okay. So let's take a look at this here. So we have, okay, so 180 goes to here. So 140, you're going to have about a 40-degree angle left. So we'll put it right there. Okay, so this is our first one. Okay, so that is the 140 degrees. Okay, they want us to use the formula to find a positive and a negative coterminal angle. Okay, so let's take a look at this. Now let's just think about this for a second. If we let n equal to 1, okay, so then you're going to have theta plus 360 times n. Our theta is 140, all right, plus 360 is going to equal, I bet you could figure that out. That's not too bad. 500 degrees. Okay, so now I want you to think about this here. Let's draw it. So if we go around 360 degrees, then we have to go around another 140 degrees. That gives us our 500-degree angle, which is coterminal, a positive angle, which is coterminal with the 140. All right, now, but the question is, let's think about this here. Now they want a negative angle that's coterminal. All right, so think about this. Let's draw another picture. Okay, this is our 140-degree angle here. Okay, so we want to go negative. All right, so let's try this. So we've got theta plus, how about if we say 360 times a negative 1? We'll let n equal to negative 1. Okay, our theta is 140 minus 360. Just don't want to make any mistakes on this. All right, 140 minus 360 gives us negative 220 degrees. Okay, so let's see where this goes. So this would be 180 from here, negative 180 from here to here. Then we would need to go up minus 180 gives us, whoops. All right, so we have negative 220. So we have 220 minus 180 gives us 40 degrees. All right, so if we go negative 220, that's the negative 220 there, and it's coterminal with our angle. All right, so the big question is, what is the homework? And then we are done. And I will see you guys today. All right, so your homework is page 552, 1 to 17 odd. All right, then we'll do 19. Yep, 19. 23. Feel free to do more if you want to for practice. 37, 41, and 45. All right. Remember, there is a 30-minute rule. I don't expect it to take you that long, but I know that everything's a little bit crazy right now. And I know things take a little more longer than we expect. All right, take care, be safe, and I will see you tomorrow. Oh, and I will put this assignment on Jupiter Ed, and please make sure to have it into me by tomorrow. Well, I mean by maybe tomorrow morning so that I can take a look at it. I think that sounds good. All right, take care, God bless you, and we'll see you tomorrow.